Welcome student stars to computer class. Yesterday we studied network topology, in which we covered star, bus, tree, graph, mesh and fully connected topologies. Today we are going to start with network devices. So let's discuss network devices. In the smooth functioning of networks, many devices play important roles. Here in this section we are going to discuss a few of them. Let's start with modem. If I tell you what is the definition of modem, a modem is a computer peripheral that allows you to connect and communicate with other computers via telephone lines. So let me tell you modem. Modem stands for MOD, that is modulation, and DEM stands for demodulation. Because ordinary telephone lines cannot carry digital information, a modem changes the digital data from your computer into analog data, a format that can be carried by telephone lines. In a similar manner, the modem receiving the call then changes the analog signal back into digital data that the computer can digest. This shift of digital data into analog data and back again allows two computers to speak with one another, called modulation, demodulation. Modulation is process of sending data on a wave. There are three types of modulation techniques used. One is AM, that is amplitude modulation, second is frequency modulation, and third is phase modulation. Now let us try to understand the working of modem. As you can see in this figure, try to understand these terminologies, and with respect to this we will be understanding. Modem converts digital signal to audio frequency tones, which are in the frequency range that telephone lines can transmit, and also it can cover transmitted tones back into digital information. After the power is turned on in DTE, that is data terminal equipment, as you can see the last one, and DCE, that is data communication equipment, the terminal runs for self-check. It asserts the data terminal ready signal to tell the modem that it is ready. As you can see, this is DTR or number 6. Now when the terminal has a character set to send, it will assert the RTS, that is request to send signal to the modem. The modem then asserts its carrier detect, that is CD, signal to the terminal to indicate that it has established contact with computer. When the modem is ready to transmit data, it asserts clear to send, that is CTS, signal back to terminal. When the terminal then sends serial data characters to the modem. When the terminal has sent all the characters it needs to make its RTS signal high, this causes the modem to unassert its CTS signal and stop transmitting. Similar handshakes occur when modem and computer are on other side also. Modem come in two varieties. One is internal modem and another one is external modem. First one, internal modem, the modem that are fixed within the computer, as you can see in this figure, and external modems, the modems that are connected externally to the computer as other peripheral are connected. You can see in this figure, this is an external modem. Next is RJ45. It is short for registered jack 45. It is 8-wire connector which is commonly used to connect computers on local area network, that is LAN, especially Ethernets. RJ45 connectors looks very much similar to standard telephone connectors, that is RJ11, but it is wider than RJ11 as it houses 8 wires instead of 4. RJ45 connector are used to connect computer in Ethernet LANs. You can see in this figure, we can see RJ45 connector with pin 1 to pin 8, and RJ45 Jack is here, And in last one we can see inserting an RJ45 connector into its jack. Next we are going to understand what are Ethernet cards. As mentioned earlier, Ethernet is a LAN architecture developed by Xerox Corp in association with DEC and Intel. Ethernet uses bus or star topology and can support data transfer rate up to 10 Mbps. The computers that are part of Ethernet have to install a special card called Ethernet. So as you can see here in this picture, this is an Ethernet card which is placed inside a CPU box. RJ45 externally is connected into it, and then this is AUI, and next is BNC connectors. So next is this figure in which you can see this PCI slots lets this Ethernet card to be inserted within it. Next are hubs. A hub is a hardware device used to connect several computers together. A hub that contains multiple independent but connected modules of network and inter-network equipments. A similar term is concentrator. A concentrator is a device that provides a central connection point for cables from workstation, server, and peripherals. In a star topology, twisted pair wire is run from each workstation to a central concentrator. Basically, hubs are multi-slot concentrators into which a number of multi-port cards can be plugged to provide additional access as the network grows in size. Hubs can either be passive or they can be active. Active hubs electrically amplify the signal as it moves from one connected device to another, whereas passive hubs allows the signal to pass from one computer to another without any change. Now let us try to understand how hub functions. Hub are simple devices that interconnect a group of users. Hubs forward any data packet including email, word processing documents, spreadsheet, graphics, print request. They receive over one port from one workstation to all of their remaining ports. All users connected to a single hub or stack of connected hubs are in the same segment, sharing the hub's bandwidth or data carrying capacity. As more users are added to a segment, they complete a finite amount of bandwidth devoted to that segment. Now next is switch. I'm showing you here, this is a picture in which switch is here as a rectangular box with 10 port. A switch is a device that is used to segment network into different subnetworks called subnet or LAN segments. Segmenting the network into smaller subnet prevents traffic overloading in a network. A switch is responsible for filtering, that is transforming data in a specific way, and for forwarding packets between LAN segments. Switch support any packet protocol. LANs that are segmented through switch are called switched LANs. In the case of Ethernet LANs, they are called switched Ethernet LANs. Next is repeaters. A repeater is a network device that amplifies and restores signals for long distance transmissions. Over distance, the cable connecting a network loses the signal transmitted. If the signal degrades too much, it fails to reach the destination, or if it does arrive, the degradation of the message makes it useless. Repeaters can be installed along the way to ensure that the data packets reach their destination. Repeaters are of two kinds. One is amplifier and another one is signal repeaters. The first merely amplifies all incoming signals. However, it amplifies both the signals and any concurrent noise. The second type collects the inbound packet and then retransmits the packet as if it were starting from the source station. Next is bridge. A bridge is a device that lets you link two networks together. Bridge are smart enough to know which computer are on which side of the bridge. So they allow those message that needs to get to other side to cross the bridge. This improves performance on both sides of a bridge. As a packet arrives at the bridge examines the physical destination address of the packet. The bridge then decides whether or not to let packet cross. Next, we are going to discuss router. A device that works like a bridge but can handle different protocols is known as router. For example, a router can link Ethernet to a mainframe. If destination is unknown to a router, it sends the traffic bound to unknown destination to another router using logical addresses which knows the destination. Next are gateways. A gateway is a device that connects dissimilar networks. A gateway operates at highest layer of network abstraction. It expands the functionality of router by performing data translations and protocol conversion. It is needed to convert Ethernet traffic from the LAN to SNA, that is System Network Architecture. Traffic on a legacy system, it then routes the SNA traffic to mainframe. When the mainframe answers, the reverse process occurs. Last, we are going to define what is Wi-Fi card. Wi-Fi card is either an external or internal local area network adapter with a built-in wireless radio and antenna. The most common Wi-Fi card used in desktop computers are PCI Express Wi-Fi cards made to fit the PCI Express card slot on the motherboard. So this is all for today, and tomorrow we will be discussing LAN design. Thank you, Shamstars. That's all for today. You can drop your queries on the Google Classroom. Take care.